Let's do one question related to theorem that we learned. Tangents from the external point to the circle is equal, right? These two tangents will be equal. We did one question previously that was related to Pythagoras theorem, and we need to find the length of two tangents. Now that concept we are going to use for the triangle and quadrilateral to find the lengths or to prove some results. Let's start. Read the question first. Triangle ABC is circumscribing a circle. Okay, so there is a circle inside the triangle. Figure is given in the question, so nothing to worry about it. How to imagine what things are given where, it's already given, so it's good. Find the length of BC. We need to find the length of BC. So you can see that there are two shapes, right? I'm talking about this top figure. Circle is there and triangle is there. So triangle ABC, right? And there are three more points P, Q, R. Okay, so P, Q over here, Q will be over here. P, Q and R. So there are 3 points are there. Done? Now what we need to find? We need to find this length of BC. And remember one thing, this circle is touching the sides of a triangle at P, at Q and at R, right? Done. So we have information of AP, which is 4 cm, then PB 3 cm. For BQ and QC nothing is given. It makes sense because we need to find that. And AC is given, whole length is given, whole length of side AC is given 11 cm, right? So how to find BC, side of a triangle, right? It's not given find BQ or QC, but we need to find BC. Okay, so question is very interesting, but you need to first of all break this figure, right? I've done that. First of all, what I've done, I have only taken this two upper side, right? So which is AP, AR. You can already see AP and AR. Now why have I done this? Can you think why have I done this? See, A is the external point. Forget this figure for a while. Forget this figure for a while. A is the external point to the circle, right? External point to the circle. Now from the same point there are two tangents AP and AR, and we know from the theorem that tangents length will be equal. If AP is 4 cm, what will be the value of AR? What? 4 cm. Simple. So AR value I already get it. Simple. This is what we are going to do. In this figure there are three external points taken together and combined. The tangents are combined. That's why it looks something different. That triangle is there. We did not learn anything related to theorems of triangle and circle together, right? But we need to break this figure down and to understand in easy way. Here, one more. Let's talk about this one. P, B and Q. So P, B and Q. If PB is 3 cm, this tangent from this same external point, that will also be what? 3 cm. So done. BQ is 3 cm. AR is 3 cm. Done. Now come to this one. I'm talking about point C, R, C, Q, right? Now here no information is given to us. No information is given to us, but we can get the information. How? See, AR is what? 4 cm. This total length is 11 cm, right? This total length is 11 cm, and up to here it is 4 cm. So can I get the length of this one? Very simple. The whole length is given 11. This is 4 cm. So subtract 11 minus 4 will give you 7. So this will be 7, right? Done. So length of RC is what? 7 cm. Now C is the external point. From that external point there are two tangents CR and CQ. If CR is 7 cm, what will be the length of CQ? That will also be 7 cm. Done. Here let us write as well 3 cm, and here as well 4 cm. Done. I'm just doing this sum orally for a while. We'll write the steps as well. Now come to the BC. BC is made up of two sides, BQ and QC. So BQ is what? 3 cm, and QC is what? 7. So 3 plus 7 is what? 10 cm. My answer is 10 cm. If this kind of questions are coming for a 1 mark MCQ, then you can do calculations orally and select the appropriate answer. Then it will be done. But if it is for a like 2 mark or like you need to show the calculations, then you need to write the steps, right? So let's start with the steps. First of all, let's talk about three external points, right, which is A, B and C. Let's start with the A. C we will talk at the end. The reason behind that, because we don't know any of the length of the tangents there, but we know for point A and we know for point B, right? So let's start for point A. Here, right, external point A, right? First external point A. So for external point A, I can write that AP is equal to AR. What is the reason behind that? Can you tell me the reason behind that? Please write this reason, that's very important. Okay, tangents from the same external point to the circle are equal in length. Done? Simple. Equal in length. Done? Simple. Write this reason. It's very important why we are equating them, right? So can I write the final conclusion? AP is equal to AR. AP value is what? 4 centimeters. So I can write that 4 is equal to AR or 4 centimeter, right? That's my length of the AR. Done? Now let's talk about the external point B. Let's talk about external point B. Here, what relation can I write? BP is equal to BQ. So BP is equal to BQ. Now what is the value of BP? Which is 3 centimeter. So BQ will also be what? 3 centimeters. So let's write BQ is equal to 3 centimeter. Done? Now these lengths we already know, easy to calculate. So I've started from those points. Now what I want to find? Okay, this AR calculation is written, BQ is written. Now can we get the QC directly? No, we cannot get. We need to have either RC or QC, any one of them. So QC we don't have any method to find because total length is not given over here. But from AC we can get the value of RC. Let's see how do we get it. We need to subtract it, right? We have already discussed. So first of all, let's write AC can be written in the form of AR, okay, AR plus RC, or CR also possible. So AC is what? 11 centimeter. So let's write 11 over here. AR is what? 4 centimeter. Just we did calculation. Plus RC. Shift this 4 over here. That will be negative. 11 minus 4 is equal to RC. So RC is equal to 7 centimeter. Now RC is done. Now what do I need to do? I will be taking this 7 centimeter calculation is done. Now let's talk about external point C. That is the only thing left now, right? Because external point A is done, external point B is done, external point C. So external point C. Done? Now what relation will I write? CR is equal to CQ. CR is equal to CQ. CR value is what? 7 centimeter. We just calculated, and CQ. So CQ is equal to 7 centimeter. That is also done. Done with the CQ. So we have the value of CQ as well, which is 7 centimeter. And here BQ is 3 centimeter. Now there is only one step left, which is addition. Add BQ and QC and get the value of BC. So let's write BC can be written as BQ, okay, plus QC. So BC, okay, BQ is what? 3 centimeter plus QC is what? 7 centimeter. That is 10 centimeters. So that's my final answer. Whatever calculation we have written now, we have already discussed orally, right? Remember this figure is just for the understanding. You are not supposed to draw it. I wanted to make sure that you understand that these two are the same tangents. Why? Because they are from the point A. That's why these two tangents are equal. Then these two tangents are equal, and these two as well. We are going to prove some results as well based on this, right? And we are going to do one more question based on this. So this is how we find with the help of tangent, relation between circle and the triangle. Figure looks very complicated, that how can we do it, triangle and circle, but it's simple. A triangle is touching the circle, it is tangent, remember, right? And just we need to divide into two parts. Three different figure will give you a proper idea. So this is how we get the length of the BC. So far we discussed sums related to finding the length of a triangle or a length of the tangent or something else, right? We were calculating. Now we are going to discuss the sums where we need to prove some results which is given in question, right? So figure is already given, no need to worry, it's good. Now let's read the question, then let's prove. In the given figure, so given is already, figure is already given. AP and AB are tangents, okay? So AP and AB are tangents, we can see in the figure, from point P to the circle with center O, okay? So let's write center O over here. So center O, done. X is a point on the circle, yes, it is on the circle, and prove that PM plus MX is equal to PN plus NX, right? So what we need to prove, this length plus this length is equal to this length plus this length. So how shall we do it? First of all, whenever you have this kind of question, always remember to find the external points to the circle. How many external points from the circles are there? First of all, one is already given in the question as well, and figure we can see very nicely that P is the external point. There are two tangents, PA and PB. Done. Is there any external point can you find? There are actually two more external points, which is point M and point N. It is not visible directly because they are on the line PA. Right, so if you see, let's forget this figure for a while and see from the M. From M there are two tangents, MA, MX, good. Then from N there are two tangents as well, NX and NB, right? So there are three external points, and for all of them we are going to write the result that tangents from the external point to the circle are equal in lengths. Same we are going to do. Then let's see we can manipulate something or not, and we can get the desired result. Let's start. So first I will be writing tangents from the external point to this circle are equal in length, Done. Remember, this statement is very important, we need to write it. So first of all, let's take external point P. Let's start with external point P. So external point P, what relation can I write? PA is equal to PB. So PA is equal to PB. Done. Now let's talk about this second external point. I told you there are three external points, which is P, M, N. Let's write for external point M. External point M. Done. So I can write MA is equal to MX. Let's write MA is equal to MX. Done. Now let's write for the third external point, which is point M. External point M. External point N, not M. M is already done. So for N, NX is equal to NB. Or let's write here that NB is equal to NX. Done. Now what to do? We know this one. Okay, we have written all the possible relation from the theorem. Now what to do? Now let's start from this only, PA and PB. Now if you see in the result that PM plus MX, okay, so we need to have PM. Now PM is a part of PA, right? PM is a part of PA, and another is given PN is a part of PB, right? So we can get at least PM and PN. First of all, let's get that one. PM is a part of PA and PN is a part of PB. So let's write first of all for PA and PB. So PA is equal to PB, right? PA, I can write that PM, okay? So PM plus, if this is PM, then what is the length of this one if I want for PA? That is MA. So MA is equal to PB. Instead of this, I will be writing two different lengths, which is PN and, okay, first of all, let's write PN, and what we have written over here, NB plus NB. Then understand this very clearly, because this is the where we are going to get our answer, right? This is the turning point. PA can be written in the form of two different lengths, which is PM plus MA and PN plus NB. Done. Now instead of MA, what can I write? See over here, MX. So let's substitute. So PM plus, what I will be writing, see properly, I will be writing MX, and here is equal to PN as it is, because see in the result what we need to prove. And instead of NB, what I'm writing, NX. So here NX, can you see, we have proved that PM plus MX is equal to PN plus NX. Simply, it was very easy. We just need to replace the relation and we can get the answer. Let's repeat one more time. So figure is already given, so it's easy to understand. And first thing I told you that identify the number of external points. How many external points are there? There is not only one external point, but there are three external points, which is P, M and N. M and N is not visible clearly, but you need to think properly and observe, right? Mention the statement theorem, very important. You need to mention why they are equal. We have written the reason why these two sides will be equal, two lengths will be equal, right? That part done. So three external point, we have written this statement. Now see, we need to get the PM. So where can we get the PM? PM is present in PA. So let's start from that point again. PA and PB. Then write them in part, which is PM plus MA is equal to PN plus NB. We have result already that instead of MA, write MX, instead of NB, write NX. Then we have proved it. So this is how we prove the results. Let's do similar question. Figure is going to remain almost same. Names are different, but we need to prove something else over here. Let's start. Let's read the question. If a circle touches the side of a triangle, okay, if the circle touches the side of a triangle, here it is given something else. Previously it was given something else, that it is tangent, right? Triangle ABC. So triangle ABC, and circle touches the side of it at P. Okay, so let's label over here as P. Here P, right? And external sides AB and AC. External sides means we need to extend little bit, okay, at ABQ and ACR respectively. Prove that AQ is equal to half of BC plus CA plus AB. Okay, let's write over here that what we need to prove, AQ is equal to half into BC plus CA, BC plus CA plus AB. Now you can see over here that AB plus BC plus CA, it is perimeter of triangle, right? Basically we need to get the sum of all three sides and should be divided by 2, right? So how shall we proceed? I told you whenever this kind of questions are coming, rather than taking as a triangle and circle, take first of all count external points. How many external points are there? So A is the external point, right? Then B is the external point and C is external point, right? External point. Now from external point to the circle, what do we get? Tangents, right? So, and we also know the theorem, tangents from the external point to the circle are equal in lengths. So let's write it, tangents from external point to the circle circle are equal in length. Done? Simple. Now, say if I want to use this statement, how can I use? First of all, let's start. External point is A. So for external point A, let's write external point A. What can I write? AP, AQ. Let's start with AQ. AQ is equal to AR. AQ is equal to AR. Simple. Now for external point B, let's write for external point B. External point B. So external point B, right? It is BQ and BP. BQ is equal to BP. Now what's left? External point C. So let's write external point C. For that it is CP and CR. So CP is equal to CR. Done? Now let's start with our result AQ. Right, so let's start with the result. What we need to prove, it will be little lengthy. Let's start from here. So first of all AQ, and let's say half is given. So what I'm going to write, half into 2 times AQ. Why 2 times AQ? Because if you write 2 over here, 2 will get cancelled and AQ is equal to AQ. Simple, right? We are thinking in a reverse manner. Okay, so 1/2 as it is. Now 2AQ. So can I write AQ plus AQ? Yes, I can, right? AQ plus AQ 2 times. Still I am not changing the whatever result which is given over here. I am not changing it. I am modifying it. Final output will be remain same. That 2 if you cancel it, it will be AQ only. Then instead of 2AQ, I am writing separating. Like 2x is equal to, we can write x plus x. Okay, now I am going to use this point. AQ is equal to AR. Okay, so first AQ. So 1/2 into AQ plus, instead of AQ, what I'm going to write? I'm going to write AR. So AR over here. Done? Then 1/2 as it is. Let's expand further because we want BC, CA and AB. Now see BA. Okay. Can I write QA? See over here that as the previous question only, QA is equal to AB plus BQ, right? I can express QA in these 2 forms as well, AB plus BQ. Simple. Same I can write for AR as well.